Let's go through Lico 790, Domino and Tromino trolling. So we are give two types of tiles, and that is one multiple by two domino, which is like the left, and also a terminal shape. So we want to form a multiple by two board to ask how many ways we can form this shape. So we'll see if the board is one multiple by two, right? So there is one way, just use a domino vertically. And if it is two multiple by two, right? It will be two way. One is vertical, another is horizontal, right? And but when n goes to 3, it goes kind of large now. You see, there is one vertical, two horizontal, one vertical, um, and sorry, three vertical, and two horizontal, one vertical. And for the terminal, the two on the up, and which is the first, and also two on the bottom is the second, or two on the bottom, which is the first, and two on the up is the first. So let's look at we can think about for this question use dynamic programming. So for dpn, right, into dp equals new into, we can have this one as n plus 1, right? Because we can have dp1 equals 1, just have a number equals this kind of I, the width. So we'll see it has dp1 equals 1, right? And dp2 equals 2, right? And from dp3, it already become complicated. So let's look at how we can derive those kind of dpi from previous states. So I draw a graph as a dp1 is a one vertical, dp2 is a one vertical, two vertical, and two horizontal. And dp3, you see, we can from dp2, right? dp2 and append a vertical terminal here, or dp1 append two horizontal domino. dp2 has append one vertical domino, and also dp2 append two horizontal domino, right? So that this one will be dp2 plus dp1. And also we can use the terminal, right? The terminal, what we can do is that we can have the two part horizontal part first, and two horizontal part below or on the bottom next. Or we have the two horizontal on the bottom first, and then two horizontal on the top first. Right? So that means this will be, let's see, dp3, dp3 will be equals dp2 plus dp1 and plus 2, right? And when it goes to dp4, you see, dp4, we can come from dp3 and append a vertical domino, or a dp2 append two horizontal domino, or dp1, you see, and we'll see dp1 can have this kind of terminals combination again, right? And also, from it can add another two states, that is using two terminal and one domino. So that is another two states. So we'll see dp4 will be equals dp3 plus dp2 plus 2 multiplied by dp1 plus 1, right? And also, here you'll see dp5. dp5 will be dp4 plus dp3 plus 2 multiplied by dp2 plus dp1 and plus 1, right? So dp6 will be dp5 plus dp4 plus 2 multiplied by for instance dp3 plus dp2 plus dp1 plus 1 and then plus 1, right? So we'll see it will always have this kind of formula that is dpi will be dpi plus 1 plus dp I plus 2 plus 2 multiplied by dp I minus 3 plus dp I minus 4 until dp 1 and plus 1, right? So from this formula, what we get is dpi minus 1 will be equals dpi minus 2 plus dpi minus 3 plus 2 multiplied by dpi minus 4 plus dpi minus 5 plus 1, right? So use the first formula and the second formula, and we are uh, uh, have a first on the dpi minus dpi minus 1 will be dpi minus 1 minus dpi minus 2 plus dpi minus 2 minus dpi minus 3 and plus 2 multiplied by dpi minus 3. And also you'll see the dpi minus 4, they are all being merged. So you will have this kind of formula that is dpi minus dpi minus 1 equals dpi minus 1 plus dpi minus 3. So that is dpi will be 2 multiplied by dpi minus 1 plus dpi minus 3. So if we know this kind of transformation formula, it will be easy to write the code. So what we do is that we are going to let's because this will be very big, right? So we need to change this one as long. And what we do is um, mm, so for this one, there is another state. Let's say dp0 is also 1. Why dp0 is also 1? That means we can consider if there is no dominance, right? We also have one state. So what we do is that for int I equals to 3, I smaller than we notice that we have dp I equals to 2 multiplied by dp I minus 1, right? Plus dp I minus 3. This is the transformation function, right? I plus plus. Then what we have is dp I equals vi minus 1 multiplied by 2 plus dp I minus 3. And we need a mod, right? Because this is the private static int mod equals right. And what we return is return int dp and So doing like this, the time complexity will be O(n) and the space will be also be O(n), right? Um, so so the things that it is possible, we need to have this if n is equals one, right? We just return one. So, but the thing is that we'll find those kind of variables only depend on the previous one and also the I-3 variable, right? So actually we can use three variables instead use a long array here. So what we need is that we can write something like long x equals 1, y equals 1, right? Z equals 1. So what we do is that we're going to have long temp equals 2 multiplied by z plus z is 2, sorry, z is 2. That is when n equals 2, that's 2, right? So plus x and mod, and then we'll have x equals y equals z, and z equals temporary, right? So in the end, what we return is return into z. So doing like this, the time complexity will be, or in space complexity will be constant. Pattern code will be very similar. So we are going to have uh, mod equals 1. So we'll also write if n equals 1, return 1, right? So we'll see we'll have x, y, z equals 1, 1, 2. For this one in range 3 to n plus 1, right? And what we're going to have t equals z plus um 2z plus x, and MLT, right? Then we're going to have x, y, z equals y, z, t, right? Um, and in the end, just a return z, right? And you put here should be self, but